Hi, welcome back to Bike Forever. So, since the last video on this Z80 Arduino Mega test harness, I made quite a bit of progress and made quite a few changes as well, actually. So, first thing to say is ignore the EEPROM and 32K RAM. That'll be for a later video. I haven't actually done anything with them yet, just apart from put them in breadboard. Also ignore Texas Instruments TI-81 graphic calculator, which actually also runs a Z80, and ZX Spectrum, obviously Z80 CPU. So I'm surrounded here by Z80s, which isn't a bad thing. So I got 0 insertion force sockets for the CPU, Z80, and the EEPROM for later, because we'll be needing to take that out to program using that EEPROM programmer. The main difference is I've sort of tidied up the cables a bit, but you wouldn't particularly notice. The main thing is I switched to using a 555 timer to drive the clock, and I got this idea off Ben Eater of his YouTube channel. So feel free to go over to his channel if you want to know how to make a computer clock. He takes it a lot further, which is what I want to do as well. He's got like a board which is a single step mode to the clock, so you can switch between it, and also I think he has a variable resistor, so you can, turn the speed up or down. Yeah, but in terms of the PC, I'll just quickly show you the Arduino code that's running as the test harness. It's pretty much the same as before, but a few changes. So yeah, this is one of the functions in the Arduino code called, I think, initialize program. I've actually written a few little machine code programs to test. I've got the opcode fetch and read cycle, write cycle working, so you can actually read from memory, write to memory, and yeah, that sort of works. And over here, what I'll do, I'll basically do a reset. Whoops, I'm going handheld with this, so it's on auto scroll on the serial output. This little program that's currently running, all it does is set the B register to 5, then goes into a loop where it increments A, and then basically writes A to memory locations, which are down there. So it's actually written 6 there. I'm not sure if you can see. So there is still a little bit of unreliability in this previous run. Don't know if you'd be able to see that, but it actually wrote 5. So I think the unreliability is just to do with the clock trigger, because I'm actually using the Arduino as one of the pins to input the clock back in, and then trigger the rest of the code on the Arduino. So I'm not entirely sure I've got rising edge, falling edge type stuff working, but it's a lot more reliable than it was generating the clock on the Arduino, so I'm quite chuffed with that, quite pleased. And next steps, I think I'll keep the test harness as it is, but try and use it more as like a different version to see and debug what's going on by actually writing proper programs on an EEPROM and then running them, and also using the memory. So there'll be a lot more glue logic required, I think, in this as well. I probably need a few more breadboards attached to this as well. So anyway, stay tuned for further updates, and thanks for watching. Bye for now.